This is the fourth video over the types of bonds between atoms. Up to now, we have covered covalent, ionic, and hydrogen bonds. A metallic bond is the electrostatic attraction between a lattice of positive metal cations and a shared pool of delocalized valence electrons. Let's dissect what that means. Metallic bonds are kind of like the weird cousin when it comes to bonding, because unlike the three prior bonds, they are not really concerned with ownership over valence electrons. In covalent and ionic bonds, the name of the game is really to exert control over another atom's valence electrons in order to get yourself as close to a full octet as possible. In metallic bonds, however, nobody individually owns any valence electrons. Rather, they are equally shared amongst everybody. Let me show you this with a diagram so that it makes more sense. As you can see, there are many positive ions arranged in a very organized structure. These are positively charged metal ions. The negative electrons pictured around them are all valence electrons which are attracted to the positive metal ions. It's this electrostatic attraction between the negative valence electrons and positive metal ions that holds metal atoms together in this structure. However, one super cool feature of this, and something you must absolutely have an understanding of, is what I said earlier. None of these metal ions actually own any of these valence electrons. Rather, the valence electrons are free to flow wherever they please throughout the metal's ions. This free-flowing movement of valence electrons is what we call the sea of electrons, or the sea of free-flowing electrons. As shown by the arrows I'm drawing right now, these valence electrons are free to literally go wherever they please through the structure. This is a principle that you need to be familiar with to understand the structure of metallic bonds. One last question to cover before we move on to properties. What types of atoms can form metallic bonds? Well, pretty much exactly what you would think. Metals. Alkali metals, your group 1 metals, such as sodium or potassium. Alkaline earth metals, those are your group 2 metals, such as calcium or magnesium. And transition metals, such as gold or iron, can all form metallic bonds. Also super important, alloys, which are combinations of two or more metals, can also form metallic bonds. For instance, steel, brass, and bronze, alloys that you're definitely familiar with, can all form metallic bonds. Alloys are actually a very interesting topic themselves in chemistry, and I have a full video over them on my channel, which I would recommend you check out. Now, moving on to the last part of the video, what is the significance of metallic bonds? Well, one of the ground rules in sciences, such as chemistry, states that the structure of something determines its properties and functions. And so, of course, the same will apply to metallic bonds. The unconventionality of a sea of electrons gives metal its very useful and recognizable properties. Let's go through each one of those properties one by one. Firstly, the conductivity of electricity and heat. The free-flowing sea of electrons can easily carry an electrical charge, or thermal heat, making metals excellent conductors of both thermal energy and electricity. Additionally, the non-directional arrangement of the ions, not being held to one another by strict bonds, results in the properties of malleability and ductility. When a force is applied to the ions in a metal, they can easily slide past one another without disrupting the overall bonding. This means that we can turn metals into different shapes or draw them into long wires. Although we can reform metals, the strength of the electrostatic interactions between them still give them a high level of resistance to doing so, which is why we can classify them as strong or resistant to deformation. This is also the reason for their high boiling and melting points. It requires a significant amount of energy to overcome the electrostatic attractions in metal. A last property that comes from our sea of electrons is the characteristic shine of metals. The delocalized electrons can absorb and then re-emit light. This is why metals can be either very shiny or dull. I hope that this video has given you a better understanding over the formation and properties of metallic bonds. Thank you so much for watching.